Welcome, everyone, to our next session. This one is actually about a pretty new project, bootc, bootable containers. Colin Walters is going to present this. I've known Colin Walters for a while from Project Atomic, and still from OS Tree, which I'm joining the conference, in fact, from an OS Tree-based laptop right now. So awesome project, and I'm sure bootc is going to be equally awesome. So Colin will tell us about it. Welcome, Colin.
Let me unmute myself. Sorry about the infinite curse. Yeah, this is something I really hope succeeds. I remember actually at KubeCon you introduced me as the inventor of OS Tree, but I hope if this succeeds at the next KubeCon, we'll be talking about bootc. We'll see what happens. It's a really new project. And we're going to talk about what bootable containers are, and there's a lot going on. But I like to start out every talk with why I do what we do, right? Why am I creating this project? Why is it important? Well, first, who am I? Yeah, Colin Walters. I work at Red Hat on Linux, Fedora and RHEL, and I also work on OpenShift, CoreOS. Wear a lot of hats. I'd like to talk about really briefly why I do what we do, or why I do what I do. It's basically because computers have just become essential to our society. Just doing anything now kind of requires a computer. And, I think it's free and open source software is a really important way to ensure that we are in control of our computers and not the other way around. So that's the why. But diving into a little bit more, specifically, why did I choose this domain? Well, in order to keep computers secure, we need to keep them up to date. And Fedora CoreOS is a derivative of the original Container Linux project, which came out and sort of had this very, I wouldn't call it entirely new, but they did a really good job of, we will have automatic updates on by default. And I didn't realize this until Red Hat acquired CoreOS, but it's actually a foundationally different mental model when automatic updates are on by default. I've said before sometimes if you log into a system and you type yum update or apt update or whatever, and the system falls over, you kind of feel it fall because you typed that command. But if you just have a server over there and on the Friday, it does an automatic update and it falls over, you didn't do anything. It's the OS vendor's fault, right? Like there's this whole mental shift around responsibility. And I think automatic updates and making sure that that they're transactional and safe, and also that you can roll back, is sort of foundational. Is so important in making sure that we keep the computers up to date, as well as containerization. So previously at the virtual devconf.cz, I talked about a lot of this technology. At the time, it was very experimental. So, and I know I'm going to fly through these slides because we don't have a lot of time, and I definitely want to make sure I have time for demos and questions. Okay. So a lot happened in the last year. We had this effort to shift OS Tree to be more of a container native tool. And again, at the time last year, that was experimental, but we've stabilized the base format. And in fact, OpenShift 4.12 uses this by default. If this is a link to the docs right here. And if you dive in, we actually have the host system fetches a container image directly for updates. And you can now derive from it for hotfixes. This is a tech preview feature, but I'm pretty excited about it. But, I want to have an impact across the computing landscape. I think it's very important to have things work in a Kubernetes context, but not every computer is going to run Kubernetes. So there's also a lot of interest in this for desktop systems. Definitely click the link here. My slides are actually at this URL. If you want to follow along, they may be linked. And of course, there's also edge systems and other types of computers. So basically, everywhere Podman goes, bootc can go. That's the idea. We actually just now are shipping official Silverblue and Keen White container images in the Fedora registry. Now, one interesting detail about this is that OCI and Docker container images are just basically tarballs wrapped with some JSON. And to have efficient updates, you really want to generate these tarballs in a reproducible way. And so RPM OSTree basically learned how to take an OSTree commit that has RPMs and basically chunk it into again, reproducible blobs. So if you dive into it, for example, Linux firmware is something like 300 megs, and that ends up in its own tarball. And if it hasn't changed across an update, you won't re-download it. And what we can look at that in a little bit. As the other thing that happened is we have a lot of examples, and I'm proud of some of the ones in this link. It's in the CoreOS org, but this technology, again, is not specific to CoreOS. So why are we here, though, right? I was talking about RPM OSTree last year. So why am I talking about something new? Well, here's the problem in a nutshell. I mean, there's multiple, but RPM OSTree has a lot of stuff. It's been successful. We have users. We're going to keep maintaining it. But the real problem is the name originally, the name and the technology were so literally the combination of some RPM stuff and OSTree. Now, the RPM stuff is kind of optional, but when the RPM OSTree project first started out, for example, it learned how to print a diff between the RPM database across updates, which is a perfect example of a nice to have feature. After that, it learned local package layering, right? Because to me, image-based updates are not about you sacrificing control over the computer, right? We produce unlocked systems that you are root on your computer, in contrast to other image-based OSs. But yeah, the name is so literal. And the problem is when we added containers to that, it just gets really confusing. For example, the RPM OSTree rebase command understands both OSTree references and OSTree remotes and container images. And at different parts in the code base, there's a lot of, I think we architected it pretty well so that the container stack is opt-in. But still, it had a large effect on the code base. And bigger picture, I think where we want to go, OSTree works. It's been successful, but I think the point of view that we want to have systems administrators and users to feel like is my OS is a container. That's where we're going. And so RPM OSTree, again, will continue being maintained, but bootc, I'll jump into this. Yeah, so it's a big change in direction that we're making here. This slide talks about the client-side package layering. Kind of our original model was that we ship a tested base image, but reuse RPMs as operating system extensions. So if you want to have something like OpenVPN, or is kind of a perfect example of a system extension. On iOS, for example, VPNs are actually a kind of special privileged app too. That's something you could package layer, and that thing works the same way as it did before. You've customized the OS, but you still have image-based updates. There's a lot involved in that, and it works. It works, but as we move to this model where the OS is really just a base image that you build in container native tools, that stuff is just less important. Maybe you still need it for hot fixes. I want to SSH to this one server, and I want to install kernel debug on it, without going out and building a new image somewhere to reproduce that exact server state. That's something we're still going to support. But I think the default is really going to shift to a more container native model in general. It's a lot involved in that. And as we go in this direction, it kind of just makes sense to align with the github.com/containers organization, because at a technical level, all of a sudden now we're using a lot more of that. And I'll talk a little bit about how both bootc and RPM OSTree today fork off Scopio, which does the heavy lifting for fetching container images. Okay, so finally, with the background, we got to what this talks about. It's about bootc, which is a brand new project. And it started out as about just 500 lines of code. And as I say in the slide, it's kind of just a new CLI that wraps the existing OS tree container tooling. So if click on this actually, since this is live, you can see here, this is kind of the graph. I guess I can make this bigger for you guys. This is the graph of how things work. Basically, OS tree is still there in the background, but it also uses Scopio and containers image. So bootc, again, just a new CLI, and we'll look at that. And I should emphasize, it's currently experimental. It's a kind of side project, because obviously we ship existing systems today, and I'm committed to keeping those working. So I'll talk about that too. But I'm pretty excited about it. I'm pretty excited about the future direction. And again, the current github.com/containers organization is sort of a big tent. And I think bootc fits in there. OK, so at this point, you might be wondering, well, how do I use this? So for the first step, if you already have an existing OS tree-based system, you can just install this. And I'll demo that in a little bit. And basically, you can just change these commands. And obviously, you can use bootc on non-RPM OS tree systems too. For example, there's Endless OS, which is built from Debian. bootc is distribution independent. But yeah, the idea, if you're already running these commands, you can just switch them to bootc. And one thing that I do want to do as part of bootc is, I don't think we did a good enough job on automatic updates in the RPM OS tree stack. In Fedora CoreOS, we ended up with this Zincati project, which is a whole other level on top of RPM OS tree. And I'm really of the opinion that we should have a very opinionated automatic updates story built into the binary. I mean, we need to support external things too, because it gets in arbitrary levels of complexity. But I think we should have a good story where you can make sure you can set up a systemd timer unit and all that stuff, and honor the reboot inhibitors and that type of thing. So another big difference with bootc is, obviously, there's no dependency on RPM. Now, I think for a lot of users, OS tree was sort of a very raw CLI. You can use it, but we never ended up investing a lot of effort into that upstream. We kind of thought of it as a library, and then other people write OS updaters on top. For example, Endless OS also has a separate OS update mechanism that uses the same OS tree library. But I'm hoping bootc is kind of shared more directly across distributions. We made a lot of fixes to the CLI. Again, the bootc switch command is a lot clearer. And again, kind of part of this vision is that you as a system administrator or user shouldn't have to know or care about OS tree if, in the general case. If you do, we've kind of failed. We want you to think of the OS as a booted container image. I got to emphasize, though, it's really important to me that we're not leaving behind existing users. Again, the OS tree stack is going to continue to be maintained for a long time. Same with RPM OS tree. We have people using this in many places. So bootc is explicitly designed to be a seamless transition from existing systems. In fact, the switch is transactional. So if you're running existing OS tree base and you rebase to a bootable container and something goes wrong, or you want to switch back to the OS tree remote, that just works. So for example, if you're running a Fedora Silverblue system, you can rebase to the new container images, try them out. If that doesn't work, rebase back. And as part of that, it was pretty important to maintain the existing OS tree semantics around the etc and var mounts. So kind of at the back end, a lot of this stuff literally works the same way. In fact, one thing I just realized I didn't mention in these slides is that the RPM OS tree package layering still works with containers. So if you rebase to a container image, and then you wanted to install, again, kernel debug just on that one server or desktop or whatever, you still can. Talk about that. So again, bootc started out, it was really small. In fact, just 500 lines of code. That's not much, right? That's something you can write in a day or two. Most of the heavy lifting is just out to other existing code bases. All that OS tree Rust code and the OS tree C code that's used by RPM OS tree 2 is just shared, and bootc linked to it. In fact, we can maybe just click on it. And if you scroll through this, it's not too much. You can scroll through it pretty fast, but you'll see here that bootc ended up linking to OStree. Yeah. Sorry. All right. Let me dive into this. So, oops, I'm on the wrong slide. Yeah. Okay. Nice. Somehow zoomed. All right. I don't know what I did there. Okay. So it started as 500 lines of code, but here's the problem. It sort of required an existing OStree system. So the exciting new thing that landed pretty recently in bootc is bootc install. So I think this is pretty neat. What this does is you run a privileged container and you install it to a disk. Now, this ended up involving a lot more code. At this point, what I want to try and do is demo that. Yeah, okay, after this slide, I'll demo it. Getting low on time, so I'm going to try and do that fast. So at a basic mechanical level, bootc install does, again, containers are just tarballs wrapped with JSON. So what we do when you run it as a privileged container is we use the tools inside the container to write to the target block device. Like, for example, creating the EFI system partition, setting up the bootloader, and all that stuff. We currently require a separate /boot partition for Lux compatibility. So that also gets created. This stuff is configurable, but we wanted an opinionated, out-of-the-box experience. And the cool thing here, I think the really cool thing, is that when you derive from a compatible base image, like let's say we ship, I'll talk about this in the future, but I kind of proposed a CentOS stream SIG that produces a base image. As soon as you derive from that image, using a Docker file or any other way, you get an installer for free. So you have an experience where you push your modified container to a registry, and you can run bootc install. So what I'm signed up to do now is a demo. See if I can run through this quickly. So what I have here is just a Fedora CoreOS Cloud VM, and it has 2 disks attached. So let me go in here, and Josh, tell me if you guys can't see the screen.
Looks.
OK, cool, thanks. So yeah, again, it's just a stock Fedora Cloud VM. And I have Scopio and Podman installed. There's no OStree here, though. So let's go ahead. If I look at LSBlock, you'll see I'm booted off this first VDA device, but I'm going to install to this second VDB. So I'm going to run this command. So what I actually did, hold on a sec. What I want to demo is a separate image here. I just realized. Yeah, OK, that is what I have. So basically what I did, let me go ahead and show the Docker file for this first. Sorry. I have this here. So I have this, which is kind of a small minimal CentOS image. OK, it's unconfigured. It doesn't have anything. It doesn't have any SSH keys or passwords. It's a generic container image. But it does have a kernel. And in this demo, I thought this was sort of hacky, but it kind of demonstrates some of the idea. Is I want to inject my SSH key into this container image. And the reason we write my SSH public key to /user is it becomes read-only. So basically, I just created a build deriving from the generic one that injects my SSH key. And you can see there's this OStree container commit command. So I have that container image. Let's step through this a little bit before I run it. Right now, I haven't signed it. So we add target no signature verification. Wipe says to remove anything that exists in the block device. Now, we do have opinionated support for setting up Lux. OK, so when I run this command, again, right now, we actually do require Scopio to be on the host. And that's because what actually happens is this container that gets run reaches out to the host and pulls the files that are being installed from the container storage. And if you'll notice here, I have --net equals none, just to emphasize this, right? What's being installed is this container image itself. And yeah, the part here was where we were pulling from the container storage. And yeah, again, just to emphasize, we set up an EFI system partition and all that stuff. So what I'm going to do now, shut down the machine. And now what I'm going to do is switch it to boot from the second disk. So imagine in this scenario, I wanted to do an install on a bare metal server. I might be booting from a USB stick or a live system. And then that took a while. OK, so now when I start it up, I'm going to be going from the second device. And I know, sorry, the font here is probably pretty small. But now, if you notice, I'm booting a CentOS Stream 9 system. Now, let me SSH to it. And if I cat etc OS release, you can see, yeah, this is booted from CentOS Stream 9. So let's look at, now the cool thing, though, is that you now have an experience after you've done an install where when you type bootc upgrade, it looks for updates in the registry. And the same way OS tree would work before, it will transactionally update in place to them. So if we look at my user etc system directory, in this root.keys, we'll see there what's in the Docker file. But the reason I chose this is because the OS tree semantics are that everything under /user is read-only. So I think a really key aspect of this is that we've transactionally bound the operating system with its config. So this does mean if I wanted to rotate that key, I would go in and edit the container build. Now, I'll talk about some future features here. But yeah, so long story short, I think I'm running out of time, so I got to get to the rest of my slides. But if I edit my Docker file, my container file, and I push updates to this registry, and type bootc upgrade, you'll get that change. So let me dive in, get back here. So that's the idea, is with bootc, your whole world is a container, a bootable container image. It has a kernel that it can install itself, and it can upgrade itself once booted. And I gotta emphasize, we're not actually running the stuff here in a container. At build time, you might run it as a container, but when you're booted, systemd or ispin1. The installer is pretty opinionated right now, but there's also a bootc installed a file system. So if you want to do anything really complicated, for example, RAID. There's a sort of infinite array of potential block setups. You can do that however you want and use bootc install the file system. So, if you're an OS or a distribution and you want a graphical installer, you could today also use bootc install as a backend or install a file system. Also, definitely want Anaconda to learn how to use both of these. So there's a lot going on. And one of the things, I've proposed a CentOS SIG for this project. And if this excites you and interests you, I'd love if you replied on the thread here and chimed in. I'd love just people to test things out. I use this on the desktop and it works. So as long as I do that, you're safe. But obviously, one of the other things that I've been thinking about a lot is support for taking this to the next step, like thinking of my OS not just as a container image, but more like a Kubernetes pod, where I can run an image and attach some config maps and secrets. Because obviously, rebuilding a container image just to rotate your SSH keys would be sort of annoying for that use case, right? Like the rebuild case is more for layering on packages and things like that. But if we support, I basically want to think about how we support a sort of Kubernetes native feel where I can literally attach config maps to my root system. Now, I should mention here again, part of the idea of bootc is that it aligns with Podman. So at an architectural level. Now, this came up in a previous chat. Someone asked, well, would bootc talk to the Kubernetes API server? No, not by default, right? The config maps would be cached in local storage. So we would definitely support a flow where an agent would bridge from an API server into bootc. And maybe in the future, we would talk to an API server by default. But I think the architecture split we have where it sort of makes sense to have a separate agent, I feel like, that would probably run as a daemon set, something like that. But this is all up in the air. love your feedback. Yeah, so I think this will significantly improve the ergonomics of things. One thing I was thinking about here, for example, is an annotation in a config map that says always apply this live, which would work for a lot of cases. That's something we could do. So when you type, but I should explain here, part of the idea is when you type bootc upgrade, it would transactionally update to both the config maps and your image, kind of like redeploying a pod, but without losing existing state, right? Like if you're using this as the desktop, we're not going to lose your home directory, all that stuff. So let's see what else here. Oops, I think, yeah. We have an issue for apply live, which is not hard. We have that code in the OS tree stack today. And so there's no reason we can't port that forward. What type of stuff? So yeah, I should say this is a relatively small percentage of my time so far, and it's experimental. Again, I think I emphasize that, but it's definitely in a situation where the iron's hot. I'd love feedback. The CLI may change. It's unlikely. I hope if this succeeds, we may be able to stabilize it by the end of the year. Maybe. We'll see. But the goal of this talk, it's new, experimental. I think it's fun and interesting. And I'm open to gather other people to try it out, ideally contribute. One thing I didn't mention, this is all in Rust. If you like Rust and operating system updates, this may be the project for you. And that's about it. I have some links, and I think I need to stop now for questions.
Okay, yeah, we have a couple of questions, one from Dan and one from Nathan that are kind of directly related, asking about different sort of boot formats, right? Dan asks about bootable ISO or cloud images or Podman machines. Nathan actually wants to know about PXE booting.
Right. So I think what we want in the future is operating systems and distributions to support tooling that takes one of these container images as input and will produce you bootable artifacts. Now, the thing is, bootable artifacts start to get more distribution specific. Like if you're talking about ISOs, there's a lot of different ways to do that. So I don't see that in the scope of the bootc project itself upstream, right? But we would definitely want to support, again, multiple tools doing that, because I see that as a really important use case. And I think going forward, what a lot will probably make sense to a lot of people is a model where you take this bootable container image and also have tools that generate AMIs or Google Cloud images and all that stuff from this. But the whole idea is your OS as a container image is the source of truth, and the disk image is just like this shell around it. It doesn't have anything really except, in an ISO case, you need an ISO file system and that type of stuff. But 99.9% of stuff's in that image. And sorry, what was the second question?
Oh, PXE booting.
Oh, right. Yeah, I think that's kind of similar. I mean, so bootc by default is intended to install persistent systems. So it owns kernel updates. Like when you type bootc update, it owns updating the kernel. Where if you're in a PXE scenario, then that's managed externally. Now, nothing stops one from having a flow where you build a container that looks like this and then extract the kernel and ramfs into a PXE compatible setup. You could do that. It would make total sense. Again, you don't really need bootc to do that though, but it does make more sense because maybe some cases you want to PXE, in some cases you want persistent.
Okay, we actually have several questions, but we only have time for you to answer one more out loud. And so if you can actually continue in the chat with the other askers. So the other Dan asked, so with bootc, you can essentially test your user space directly using Podman. And only for the kernel, you'd need either a VM or bare metal. I'm not sure what he's actually asking, but for the first one, testing user space using Podman.
Yeah. No, that's right. Absolutely. I think it's really interesting because we have it's a dual use case. But I think in a lot of flows, you do want to, just to elaborate on this really briefly, with this, you can have a whole CI/CD pipeline that, tests your OS as a container image, maybe passes it through a security scanner, like in a container native way. But then you do want a flow that takes the next step after that and maybe boots it as a virtual machine using QEMU or provisions a machine in a cloud scenario and then rebases to it. So you might use an existing disk image and then rebase to it and verify it. So yeah, absolutely, it's a dual flow. Yeah.
Okay. Thanks very much. This is really interesting. I look forward to you using in the future. There are additional questions and additional discussion. This chat will stay open for half an hour, and of course, the event chat will stay open for the rest of the day, so people can further discuss things with Colin on the chat. In the meantime, the next session, which is on Finch, is already starting. So people who are watching should skip over to the Finch session and do any additional discussion of bootc via chat. Thanks, everyone.
Thanks all.
And don't forget to fill out the survey.
For people who are still here, I don't see the chat. Ah, never mind.
You found the session chat, Colin? We got questions from Sergio and Michelle. Yeah, there we go. Okay. Okay, I'm gone. Enjoy.
I found. Thanks. Ah, okay. Yeah, I guess I can do that too. So looks like Sergio found it. So yeah, we had a question about integrity. I think that's a super important topic. And long story short, there's a lot of trade-offs involved in this, and it's kind of important. I think there's still a lot of use cases for unlocked systems. It's a sort of default. Taking it out one level, if you were managing your standalone Linux desktop or a standalone pet server, would you go to a flow where you did every configuration on some remote server that signed that state? You could absolutely do that. But I think we should make that ergonomic, but there's definitely, I think, still use cases for unlocked systems, and that's kind of where we were coming from, because there's too many configuration flows that just expect to be able to change the local system. Like, how do I enable FIPS mode and all these type of things. But yeah, we're gonna move more towards like supporting sealed systems in the future.